Hi guys, welcome back. I'm Craig and I'm a software developer in the UK, currently working as a front-end developer, and on this channel I'll show you how modern web development is done. In this video we're going to explore one of the most crucial concepts in CSS, and that is the concept of specificity. I'm going to have to say specificity probably 50 times in this video, so let's see how many times I get it wrong. So if you've ever tried to apply style to an element and find that for some reason that it just won't apply, well, this is the video for you. It's going to clear up why these strange behaviors happen and how we can go about avoiding them. And that's what specificity is about, really, learning how some CSS selectors, which we've covered extensively in previous videos, are more specific and will override other selectors. Learning to master the idea of specificity is crucial to effectively using CSS in your projects. Before we get started, I'll just say that we're on all of the main social media platforms, so if you want to join us on Twitter, Instagram or Facebook, then we'd be really happy to see you there, and the links for everything is in the description below as always. If you're finding the content on the channel useful, then please smash the like button and subscribe. We're posting as often as possible, so remember to click the bell and get notified when new videos drop. The more engagement the channel gets, then the more that YouTube will put our videos in front of people that can truly benefit from them and learn from the content. Okay, so let's imagine a situation where we have different selectors trying to apply color to a paragraph element. How does CSS know which selector's color value to apply to the paragraph? So let's figure that out. Here we have this simple paragraph, and let's say that I want it to be blue. That's fairly straightforward. We'll select the paragraph and say color is blue. And then when we save, nothing happens. I'm definitely selecting the P element here, but this blue color is simply not applying. Let's test it on the H1 to see if I've made some mistake, and we see that that's working perfectly fine. But changing back to selecting the paragraph doesn't work. So what in the world is going on here? Why can't we make the paragraph blue? Well, the answer to that question lies with specificity. So over here on MDN, it says that specificity is the means by which browsers decide which CSS property values are the most relevant to an element and therefore will be applied. So here the browser is using specificity to keep our paragraph this black color rather than the blue color that we're after. You'll notice that the paragraph has an ID and a class, and if we scroll up in the CSS pane, we see we have this ID selector that is applying this black color. If we comment this ID selector out and save, now our blue color is finally applied. The reason the paragraph element selector styles were not applying and the ID selector styles were is because ID selectors are more heavily weighted than element selectors due to specificity. So where there are clashing style declarations, in this case we had two clashing color declarations, the styles coming from a selector with a higher specificity score will take precedence and be applied to the element. So let's explore this idea further with some examples in VS Code. I have a simple project open here, and as always you can find the links to the code in the description below. All I've got here is a simple HTML file that has a linked style sheet. To get a hold of this code, you can go about it in a couple of ways. You can either download it from this GitHub repo using this green download button, and then once you have it, you can open it in your text editor of choice. That's VS Code in my case. It contains both the starting files where I'll begin from in this video and the files in the state that they will be in at the video's conclusion. Alternatively, you might not have the option to download the project if you're working on, say, a public computer or in a library or a school, so you can find the same project here on CodePen. You don't need to create a CodePen account to work with this pen, and you can start coding as soon as you open the link. It does help if you do have an account, and I would recommend it as CodePen is great. It's free and you can save any pens you work on to your own profile and then come back to work on them later on. So we have a simple bit of markup here, an H1 nested inside of a div. The div has a class of container and the H1 has a class of heading and an ID of main. We learned in the last video that because of inheritance, we could apply styles to the div that would be inherited by its child elements. So in this case, we see the H1 nested inside the div is inheriting this green color. We could also target the H1 by name, so we'll create an H1 selector. This is an element or type selector, and this time we'll give the H1 a color of white, a white border, and we'll give it a little bit of padding. And our H1 now has some styles of its own coming from an element or type selector. Our H1 has a class attribute, so we can also use a class selector here. So by adding styles from the class selector, these will be applied to the H1. Let's say we want some dark text, and we'll use this turquoise blue green color again to give the H1 a background color. So if we inspect the H1 now, and in DevTools go to the Styles panel, we can see the styles being applied to this element. We can also go down and use these checkboxes to toggle styles on and off. We can see that we have color coming from the H1 selector that's crossed out, and color coming from the .heading class selector, which is actually being applied. If we toggle the color coming from the class off, we have the whites from the element selector applied again. So we have two clashing style declarations, and of course the reason that the class selector's color is winning is because class selectors have a higher specificity score than element selectors. It isn't just because this selector is lower in the style sheet. We can move it higher in the style sheet, and if we save again, the styles will still apply due to the class selector being more specific than the element selector. Specificity only applies when the same element is targeted by multiple clashing declarations. The style that is applied is the style coming from the most specific selector. In this case, that is the class selector, which is more specific than the element or type selector. Our H1 also has an ID of main, so let's select the H1 by its ID, and we'll have a color of cornflower blue, a background color of silver, and let's also add a border, and we'll give this as well the color of cornflower blue. Again, we see that the styles from the ID selector are applied. We have 3 color clashes and the ID wins. A background color clash between the ID and class, and ID wins. And a border style clash between the ID and the element selector. So in all of these cases, the styles coming from the ID selector are deemed more specific and are applied, overriding any clashing styles the browser finds coming from less specific selectors. So we have a ranking or weighting of sorts here, and shortly we'll look exactly how this specificity score is calculated. In the case where there's a clashing style declaration from 2 selectors that have a matching specificity, so if the specificity score is tied, then the selector furthest down the style sheet is going to have its style declaration applied to the element, and that's because the browser reads the style sheet from top to bottom. So I'll duplicate the main selector and change the text and border color to yellow, and we see that we now have 2 matching selectors with exactly the same specificity, and the style applied comes from the lowest in the style sheet. If I switch the order of the 2 main selectors, then we get our cornflower blue back, as that is now the furthest down the style sheet. Also, the order of the link tags that we use to include external CSS files to our HTML page is important. If we have 2 separate style sheets that each contain matching selectors or selectors with the same specificity score, then the style sheet that comes second or lower in the HTML file will always override the first. So if I go to the HTML file, and we'll add another link tag here, and this time I'll link to a style sheet called style-2.css. Now I'll create this file, and once we've got this file created, we can go into it and we'll add another main ID selector, and this matches the one that we have in the first style sheet exactly. So it has exactly the same specificity score, and now if we say color is navy and save, you'll see that the style updates. We have 3 matching identical selectors that are clashing, that have the exact same specificity, and the one that has won is the one that is coming from the style sheet connected by the link tag furthest down the HTML document. If we move this link tag up above the original link for the style.css file, then you'll see that the styles update again, and the original link tag, the original style sheet is lower, and the styles coming from that style sheet will win. Okay, so here I have this image which demonstrates the main common selector types of element, class and ID selectors, and also inline styles ordered from the highest to the lowest specificity. Inline styles are those which we include inside the opening tags of HTML elements, and we see that in order, type or element selectors are the least specific. Things like h1, p, div, etc, etc, and these will be overruled by the class selector, which has a higher specificity score. So this would be something like dot heading, or we could have a dot container class here as well applied to the div, and this would be more specific than just selecting the div by its element name. The class selector in turn is less specific than the ID selector, and we saw that our hash main selector overruled any clashing styles applied by the heading class selector. We see that inline styles have a higher specificity even than ID selector, so let's try that out. As we said, we can add inline styles inside the opening tag of an HTML element using the style attribute. So our h1 has styles applied to the element directly and coming from the class and ID selectors. Let's add a style attribute and say style is equal to color magenta. And when we save, we should see that our text is now magenta. So inline styles will overrule all of the main selector types in all instances due to higher specificity. There is still one more rule we can use to override any other selector declarations and also to override inline styles, and this is something called the important declaration. This important keyword is preceded by an exclamation mark, and it can be added to CSS property values to override more specific styles. So when we use the important keyword to the value of any style declaration, it will automatically override all other declarations for the targeted element or elements. So let's look at our H1 in DevTools. So at the moment we have the inline styles adding a magenta color. We'll take that off and we have various colors coming from our various main ID selectors. If we toggle those off one by one, our heading now has this dark black or charcoal color coming from the class, and then when we remove that, we're back to the original color declaration. So we can see how specificity is actually working here. This original color declaration on the element is being overridden multiple times by more specific selectors, which are in turn all being overridden until we get to the inline style, which has the highest specificity and is winning the battle to have its color declaration applied to the element. As I said, we can use the important keyword now to override inline style. So if I head back to VS Code and I'll go to our least specific selector, which is the H1 element selector, and inside the value for the color declaration, I'll create some space and add an exclamation mark and the word important, and for the hell of it, I'll also add it to the border as well. Now, despite all of these selectors with higher specificity scores, when I save now, we see that the addition of the important keyword to the least specific, or any other selector for that matter, means that all other clashing style declarations are now overridden. However, we should note that at this point, using the important keyword is considered bad practice in the real world in most cases, because it can make our CSS code much more difficult to understand and debug. It's much better practice to use the specificity system, and important should be used as a last resort really when all else has failed, or in cases where you might need to override styles from an external UI library like Bootstrap, for example. But even then, if you're using your selectors correctly and making use of the specificity system, then you shouldn't ever need to use the important keyword. If you do find yourself with no other option, it usually means that there's a better, more efficient solution for you to consider and to go back to. Of course, you can't always help using the important keyword, particularly in the workplace. Sometimes you go in and there'll be an enormous CSS code base which has been contributed to by several developers over a course of years, and sometimes it's so big that debugging it and working with it is really an impossible task. So any new developers that come in and change the styles will just put something at the bottom and then use the important keyword in those cases. But where you can avoid it, please do, because it is bad practice. In a situation where you have two conflicting style declarations that have the important rule added to them, say for example if I come to the heading class and add it here, then the declaration with a greater specificity will be used, and if we save we see that in action. And it isn't because it's lower in the document. If I move the H1 selector lower than the class selector in the style sheet and save, we see that the more specific class selector with the important keyword wins. Okay, we know what specificity is, and we know the hierarchy of which selectors are the most specific. We also know that inline styles are going to beat selectors, and we know that the important keyword is going to beat that. So the last thing that we're going to do now is look at how to calculate specificity scores ourselves, so nothing too heavy. We can group the scores into 4 columns, which we'll call A, B, C, and D. And if we look again at this image from earlier, we have a specificity ranking from the most to the least specific. So column A would be the most specific inline styles, and column D is the element selector, which is the least specific. Each number that we add to our specificity score represents the number or count of selectors for the element in question. So let's add a new P element underneath the container div with 10 words of lorem ipsum placeholder text, and in my style sheet I'm going to add a P element selector and we'll say color blue and save. So here the styles from the element selector have a specificity score of 0001. If I now add a class attribute to my P element called paragraph and then head back to the style sheet and add the selector for this class, and when we've added that, we'll say that we're going to have the color of green, and the specificity score for this one will obviously go in the C column, and so the score will be 0010. And if we changed list selector to p.paragraph and the color to purple, then the specificity score changes. Sure, we're still selecting the class, but only when it is on P elements here. So it's different to just the straight class selector, and we'll see that if we add the paragraph class in again and the color green, it loses out to the p.paragraph selector, which has a specificity score of 0011. When an element has an ID selector, we would add 1 point to column B. So I'll add an ID to our paragraph of text, and then in the style sheet, the selector to apply those styles. So the specificity score here would be 0100, and it overrides what we already have. If the element has an inline style, then we would add 1 point to column A. So let's add a style tag, and we'll have a color of deep sky blue. So in this case, the specificity score would look like this. It would be 1000. So this would make it win over all other selectors, which of course are counted in these other columns. A popular tool to calculate specificity is the Specificity Calculator by Keegan Streets, which can be found here at this link, which is of course down below in the description. You can play around in this sandbox environment by adding various kinds of selectors, and it will give you the specificity score underneath. It doesn't account for inline styles, so you would just need to add a 0 in front, but you can keep adding things and it will give you the specificity score for whatever you enter. Generally, these calculated scores can be read as a single number, so an element with an ID selector has a score of 100 and an element with a class selector has a score of 10, for example. Therefore, the ID selector beats the class selector because we know, of course, that a score of 100 is higher than a score of 10. However, it is important to note that we use commas and divide numbers into 4 columns for a very specific reason. And the reason is that if an element had a selector which included 25 classes, for example, the score would be written in column C as 00250 and not as 0250. So there is a distinction. These 25 classes don't add up to beat an ID selector. The ID selector is always more specific, and a single ID selector would have a higher score because its score of 1 is placed in the B column. So 0100 beats 00250. So even if a specific column has a double-digit score, it still won't win over higher specificity selectors. One last tool that I'll show you is CSS Stats. We have this search bar and we can enter any URL and they're going to fetch the CSS data used on that site at that URL. So let's go with their suggestion and look at google.com. We get back this data, which gives us this info on the selectors, the declarations, and what properties are most common, the colors that are used, the typography and fonts. And just down here, we have a graph on specificity. The x-axis at the bottom represents the file from line 1 down, going left to right, and the y-axis represents the specificity score. With all of these peaks and troughs here, the file looks to be a little bit erratic, to be honest. What you would want to see is a general slow and steady increase in specificity as you move down the file. If something has a higher specificity at the start of a file, then you have to be much more heavy-handed in your choice of selectors to override the effect that it's going to have on your page. This page here gives us info on something called the Specificity Graph, and I recommend you read this in full as it's a really good resource on how we judge the health of our CSS specificity. We see here it's saying that we want to avoid these peaks and troughs that we just saw at google.com, and this kind of graph shows a poor distribution of specificity. Instead, we want an upward trending graph which represents CSS that is written in order of specificity. Low specificity scores at the beginning of the project, followed by increasingly specific selectors as we move down the file. A much better but not perfect graph comes from GitHub, and we see a very gradual increase in maximum specificity as the file progresses. So best practice when we're creating our own CSS files is that we're going to write them in specificity order. We start with low specificity selectors at the beginning of the file, like type selectors, followed then by class selectors, then ID selectors, and so on. Okay, so we'll stop here. Specificity is one of the most important aspects to understand in CSS if you want to know how to apply styles to elements efficiently. Familiarity with specificity rules allows us to understand issues in situations when certain styles aren't applying where we would expect them to apply. It also allows us to write organized and maintainable CSS code with optimized selectors that burrow down into our document, targeting only the elements that we intend. So thanks so much for watching. Join me in the very next video, which will be on BEM notation, and BEM stands for block element modifier, and it is a popular naming convention for the use of classes in HTML and CSS. It helps us to better name our classes in a more ordered and structured way that makes sense and provides order to larger bodies of markup. It's also really useful when you're working with CSS preprocessors like less or Sass, where we can nest related selectors. So when that video is ready, it will appear up here. So hop on over and let's learn how we properly structure the naming of our classes using block element modifier or BEM notation.